Alright guys, in this video we're going to review two important topics about ionic compounds. The first one is how do we write the formulas for ionic compounds, and the second one is how do we write the dissociation equation for ionic compounds. This slide shows you four tables, and the first one here is some important main group ions like lithium, sodium, potassium. They are positive one charge, two positive charge. It depends on which group you are talking about. The second table here shows you some common transition metal ions. Transition metal ions usually would have more than one charge. For instance, copper could be 1 plus, okay, could be 2 plus. It depends on the chemical reactions you are talking about. Alright, this table shows you some important anions. Like a fluoride, chloride, bromide, okay, and the oxide, sulfide. And the last table here shows you some important polyatomic ions. Now, the first topic, how do we write the formula for ionic compounds? The most important thing that you need to remember when you write in the formula is the charge has to be balanced. Let's start from something simple. If you have sodium 1 plus and a chloride. Now remember the charge has to be balanced when you write the formula. Now sodium has one positive charge, chloride has one negative charge, so when you combine them together the charge is balanced, and this is the right formula for sodium chloride. How about this? How about calcium 2 plus and chloride? Well, when you look at these two ions, calcium has two positive charges, chloride has only one. So you need one more chloride to balance the charge. Okay, so when you write the formula, that is a calcium Cl2. The 2 here means in each calcium chloride molecule, you have 2 chloride anions. That's the meaning of the 2. Alright, let's see this example. The iron 3 plus and the sulfide S2 minus. Now again, if you combine these two ions together, the charge won't be balanced. So let's try to balance the charge. If you have 2 iron 3 plus, then total you would have 6 positive charges. Now that means you need total 3 sulfide S2 minus to get 6 negative charges. Okay, so in this case, you count the number of the iron and the sulfide separately. You get in iron sulfide, that would be iron 2 and sulfur 3. And this is the formula of iron sulfide. Let's see some examples involving polyatomic ions. Same strategy. For instance, if you have sodium cation and carbonate, CO3 2 minus, you need 2 sodium to balance the 2 negative charges of the carbonate. Okay, so when you write the formula, that would be Na2 and CO3. This is a sodium carbonate. How about this? Copper 2 plus and the nitrate, NO3 minus. Apparently you need 2 nitrate to balance the 2 positive charges from the copper 2 plus. So when you write the formula, 1 copper, now you have 2 nitrate, right? Because you have 3 right here, if you write the 2 right beside the 3, it's going to be a little bit confusing. In this case, we use the parenthesis to isolate the NO3, and we put the 2 outside the parenthesis. Again, this 3 means in each one of the nitrate anions, you have 3 oxygen atoms. The 2 here means in each copper nitrate molecule, you have 2 nitrate anions. Okay, so that's the difference between these two. So, all right, so this is the first topic. You guys can just choose the ions you want and combine them to practice how to write the formula. All right, so this is the first topic. Now let's take a look at the second topic, how we write the dissociation equation for ionic compounds if you have the formula for them. Let's see the first one. If you have magnesium chloride, okay, how do we write the dissociation equation for this ionic compound? Before dissociation, it's solid. Okay. Now, remember, if you are familiar with the table I showed you in the previous slides, magnesium is 2 plus. Okay. So when it dissociates, remember this is the metal part and this is the non-metal part. So dissociation means that you cut them open or you take them apart. So magnesium 2 plus in aqueous solution and chloride. Okay, and chloride. But we are not done yet, because when you look at this equation, the two things that I need you to remember here is, the first thing is the elements, the number of the elements. Okay, the number of the elements has to be balanced. And the second thing is the charge has to be balanced. So when you look at this, you have one magnesium, that's okay, on the two sides, so magnesium is good. But when you look at this chloride, you have two chlorides on the reactant side, but you only have one chloride on the product side, so it's not balanced. So you have to make sure that you have two chlorides on the product side. And again, if you check the charge, you have two positive charges and you have two negative charges. The charge is balanced. You are good. Let's see one more example. How about potassium phosphate? You have a formula like this. Again, this is a metal part and this is a non-metal part. The non-metal part is a polyatomic ion. So you just take them apart. Before dissociation, it's solid. Okay. Now you have potassium in aqueous solution, and you have phosphate, PO4 3 minus. Okay. Now again, if you check the number of the element, you have 3 potassiums and you have only 1 on this side. So you need to put the 3 in front of the potassium to indicate that on the product side you have 3 potassium cations. All right, this 3 comes from here. Okay, if you let me connect that, the 2 comes from here. Okay, and the PO4 3 minus, since it's a polyatomic ion, it's just itself. It won't dissociate to smaller particles, so it's PO4 3 minus. That's it. Okay, now let's see these two examples. Sodium sulfide, okay, and zinc nitrate. Okay, so these two examples. Now I want you to stop, to pause this video for about 3 minutes, and then you resume this video and we're going to talk about them together. Alright, welcome back. Now for sodium sulfide, in each one of the sodium sulfide molecules you have 2 sodium. Okay, so well, if you're not sure, you can just write the sodium cation first and then you balance the charge. Sodium cation and sulfide as 2 minus. Alright, now if you're not sure how many sodium you will get, you take a look at this. Because the reactant side is neutral, the product has to be neutral. So before and after the reaction, before and after the dissociation, the charge is balanced. So when you look at this, you need 2 sodium cation to balance the 2 negative charges from the sulfide. So you have to have 2 here. Again, if you check the number of the elements, you have 2 sodium here, you are good. Again, if you wanted me to connect the 2 here and here, tells you where that 2 sodium cations come from. For zinc nitrate, you can write the zinc 2 plus first, and the nitrate. Okay, the nitrate NO3 minus. Again, this is a polyatomic ion. It's not going to dissociate, so this is the formula for NO3 minus. Because you have two NO3 minus on the reactant side, so you do have to have two of them on the product side. So the charge is balanced, the number of the elements are balanced, so you are good. Again, the 2 comes from the formula of the zinc nitrate. Alright, so I hope this video can help you refresh your memory about what you learned in Chem 2. And we are gonna use this kind of materials later on when we discuss the solubility product. Okay, so if you have any questions, please let me know.